Okay, welcome everyone to Module 5, Economic Simulations and Modeling. So this is the lecture for today, and wh what we're going to be going over today is what we want to do before we actually launch. And again, my name is Kwame Bryan, and I'll be your instructor. So a quick overview is why do we want to actually simulate these different types of scenarios in our Web3 games? What can go wrong without testing? I think this point answers itself. And what tools are there out there that we can use to help us with designing, balancing, stress testing the economic models in our Web3 games? So, what are the roles? What is the role of simulation in token engineering? One of the major things that we want to take into account here is that we want to anticipate players' behaviors, define any types of edge cases that there may be. For Web3 economies, the biggest thing that we run into is inflation. How many tokens are being released into the game retrospective to the amount of players that are in the game and the overall need of the economy to sustain the game itself. The drain, this is where there's like an influx. This deals into inflation again, where there's like an influx of tokens that are in the game and they're being drained out or being sold off because there's maybe not like a direct need for those amount or the excessive amount of tokens that are in game. So players will keep what they need and then selling the excess. We want to mitigate that. Like with Web3 games, we have these economy-driven game mechanics, and that's just a per core of Web3 game design, Web3 game development. We can't get away with that. That's really what initially draws more players in is that there's like this economic incentive to being good at the game or, completing specific types of tasks. What are our speculation threats? This delves into whales that have a huge, large supply of the tokens. Some things that we're going to talk about, this is more into the design of the actual token itself, but maybe having like an anti like whale mechanism in the token design itself so that there's not one sole entity that can accumulate a massive amount of tokens and then retrospectively dumping those tokens onto the market. So the role of simulation is again to we want to reduce the guesswork. We don't want to find these things out when our game is live. So we test for these things in an iterative process along with the game loop and the coinciding economic game loop. So some of our common goals is basically testing the token emission and burn rates if you have them in your game as a per core to designing your in-game Web3 economy. Having burning really helps balance things out. So in the initial design, and as you're going through these lectures, I'm hoping that you're writing down notes and you're playing your own game and looking for where a lot of these points in the token engineering process can be related to how your actual game is being designed and marrying the game loop with the actual economic loop. Testing churn, this is basically player drop off versus the retention scenarios. So where are certain situations where, the player just doesn't want to play, they don't see any incentive to continue on, and how you can mitigate this with enabling certain types of, retention scenarios. So what's a retention scenario? We have a weekly prize pool for the top tier players. That's a retention scenario. That is something that will keep your players engaged because there's an end goal that they see at the end of the week. If I am the top player, then I get this particular prize. I'm going to continue. Now, can we balance that with the game loop with this economic incentive? Of course. Players will only play a game for so long if it's only based on a economic incentive. You can keep them there, but you're pulling out of bank in order to keep players that are not really engaged with the game and probably would not forward this on to another player. Now, taking this into consideration, there is always, like, even in the Web 2 world, and a lot of the ideas that we have in Web 3, as far as, the initial game loop is directly inherent to Web 2 games. Like, let's not kid ourselves here. Modeling whale impacts and bot behavior. Botting is a huge, problem in Web 2 games. Web 3 games make this paramount more because of because there is a higher economic incentive in order to do these types of things. So we need to model this out as well. And if botting and, group botting to gamify the game to extract the value out of our Web3 games. This is where these simulations come into play. And validating some long-term sustainability. We wish for our games to last forever, and then when we're gone, that they are still being played and just enjoyed. And we want to see that if there is some validity to the way that the game loop and the economic loop and how those two coincide, does that work? Does that model work? So CadCAD is an open source framework that is designed to simulate or to create simulations. It's designed for Web3 token economies and allows an agent-based and system dynamics modeling. So we can model out different types of scenarios, how players would react based on specific types of balances, based on duration of time played, how the token emission over, say, a year or 2 years or maybe months, how does that affect the game? How does that balance within the overall economy? And then we can actually tune these parameters and put together better distribution models and to intensify the player incentive to play more, draw in more people, and just overall have fun and make sure that the game is balanced. So, what are some of the components, some of the major things? These are going to be things that change state or our state variables, our token supply, player wallets. Do we have any policy functions? These are based around the game mechanics of our game. This could be some, as we have an example here, play to earn logic, staking rewards, state update functions, how policies affect over time. So we have these state updates for the player progression, the different levels, the different items that they are collecting throughout the game. And over time, how do these policies affect the game and the longevity of it? And then simulations runs where we have these different scenarios that we've modeled with the game design team and the developers, and we are running these scenarios across multiple iterations to get a larger sample set over a longer timeline. So a daily quest model, and this is taken from the Voxelverse. So players earn tokens via the daily quest. So we have a quest system, and each time the player like logs into the game, they have a specific quest. They perform some tasks. They earn rewards or are eligible for those rewards. So spend tokens on upgrades or withdraw. So you want to balance this. What do I mean? So say that our players are earning tokens for doing these daily quests. Now, for them to progress and get, say, more tokens or an enhanced, withdraw of tokens, we want them to, spend a bit in order to earn more. So now there's this positive feedback loop for the player. I'm a player. I do this daily quest. I get, say, 10 prospect, and I need 3 prospect in order to upgrade so that when I do the next task, I might get 12 prospect. I'm just digressing. This is not, baked into the cake. I'm just giving an example here. So the model will show rewards exhaustion or inflation risk. This is where we are say like, okay, maybe this model works with 10 players, but does it work with 25 players? Does it get totally broken if 50 players come into account? And this is probably where a lot of Web3 game designers, especially game designers that are coming from Web2 into Web3, really fall short. The in-game economy for a traditional Web 2 game does not have the economic and incentive to it that where in a Web 3 game we need to think about these types of different scenarios. Traditional Web 2 games is where you're using this token and there's a direct need to use it all the time because the major worth of the in-game currency is within the game itself. In Web3 games, this is totally not the case. We have a situation or a scenario where the player can use the token in-game, but there is more than likely a dollar value for this token outside of the game. So take this into consideration when you're modeling these systems out. And then we tweak for, reward formulas, add, burn, and sync to fix and balance these things out. And we've talked about this in previous lectures, but it's going to be a reoccurring theme because of the game loop and the economic loop, and they have to be in synergy for these things to work and to be balanced. So other modeling tools, TokenSpice is an agent-based testing for our smart contracts. Machinations is visual modeling for game designers. And spread-based models using Excel or Google Sheets or something like that. They all work. Anywhere where you can basically model, create some formulas, derive, time-based in incurrences, things like that. Any tool is good, but there's a few that are designed specifically for these goals. They're listed here, and we will go over these as well. Best practices for economic modeling. We always want to simulate before we launch, right? We want to run this simulation over and over and over again. Talk to your friends, family, everybody, get a lot of different input. Always, if you can think of this ahead of time, always go for the worst case scenario, right? Always go for, don't think of it, well, I'm only going to have 100 players, Kwame, and I know that this is going to be the truth. So we're designing this for 100 players. Well, that's all fine and dandy. The models work great, Kwame. 100 players is fine. But then 101 players in this thing is totally broken. So always think of the most extreme case, right? Like we thought we're going to have 100 players, but we now have 1,000, or we have 10,000, or this game absolutely blows up and it has 1 million downloads on Steam. Does the economic model still work, or is there issues there? As I said before, share models with your community, advisors, friends, family. If you're in a Discord group of, like-minded Web3 game developers, throw it out there. The biggest, and this is, I'm talking about myself here. My biggest mistake and a lot of the things I've done over my career is asking for advice too late, and or not asking for advice and help at all. So the more people that you can get to look over your stuff, the more input that you can get if you can release the ego and allow direction, you can always learn something new. And with game development, game design, the reason why I love this industry and have been in it my whole adult life is that there is always a new challenge. There's always something that's never been done before. And I guess that's the beauty of it. So we're constantly always learning, and there's always someone out there that has a piece of advice that we, at the time, we might think that is totally, negligent to whatever we're doing, but comes down later on to be some of the best information that we could have achieved. Again, on this last part here, document our assumptions early. As we are talking about, we have 100 players and 101. Does that model work? Even if we say we have like a like online game and we can only have a certain amount of players on, and but always think about what would happen if we extend this to more concurrent users. Does the game loop and the economic loop still coincide? Run multiple scenarios, bullish, bearish, and on the exploitative side, right? Think of all these, think outside of the box. Use AI to help define some of these scenarios, or to stress test them itself. And when you're using AI, just don't write like, oh yeah, try to do X, Y, and Z. Really model it out using your imagination, and use your imagination as the springboard for what AI can, help assist or create additional educations and things like that. So, what's coming up next? Governance design in games. I love this topic of governance design in games. Having communities have a more of a direct input into how games are designed, updated, things like that. I think that this is one of the best parts of Web3 game development, is how the overall gaming community can be involved. We're going to learn how to empower your players to fair, decentralized decision making. And that's all for this lecture. And I'll see you guys in the next one.